products or the answers to special multiplication problems. There are two kinds. One is a difference of squares. Peyton, do you need something to write with? Okay. So difference, what does difference mean when you're talking math? Subtraction, right? We should be thinking subtraction when we hear the word difference in a math class. Now squares, you may be thinking of an actual square, but what we're talking about are expressions that are squared or raised to the second power. Okay, so a difference of squares basically means we're subtracting two squared expressions. Make sense? And the other one that we're going to be talking about today is a perfect square trinomial. So we know it's going to have how many terms? So this product will have how many terms? Lee, 3. Lee said 3. Tri means 3, right? A perfect square, we're not talking about the sheep square. Again, we're talking about a squared expression or an expression raised to the second power. The first one we're going to talk about is the difference of squares. And I'm going to simplify these two expressions, and then we're going to see if we can figure out what the shortcut would be. So all we're doing today is shortcuts. Normally, unlike you must show work, you don't get credit if you don't show work. Today, with the exception of the word problems maybe, and I'm going to do one of those with you, you don't need to show work. The whole point is here we're learning a shortcut, no work. Okay? If on a test you can't remember the shortcut, then you can do it the long way. But it is kind of important that we learn these shortcuts because later on, when we come back from the holidays, we're going to be factoring these products. So we're going to be going backwards. Like right now, we're multiplying to get the answer. After the holidays, they're going to give us a product, and we have to write them as factors. Okay? So we want to try to learn the shortcut. So let's look at this, see what our answer would be. So this would simplify. N times n is n squared. N times 1 is n. Negative 1 times n minus n. And negative 1 times 1, that's minus 1. So n minus 1 times n plus 1 is equal to n squared. And what's n minus n? What's n minus n? 0, right? 5 minus 5 is 0. A lot of times, for some reason, kids want to say n, or they want to say 1. But if you have 5 of something and you take 5 away, you have 0. If you have n of something and you take n away, you have 0. So that simplifies to 0. So all we have left is n squared minus 1. So let's look at this one. This is what we did in our homework yesterday. We multiplied number times number, variable times variable. So 8 times 8, a squared times a squared, 64, a to the 4th. A squared times negative 4, number times number, negative 32, and I don't have anything to multiply the a squared by, so it stays a squared. 4 times a squared, number times number, positive 32, a squared, and 4 times negative 4, negative 16. So, the middle terms are like terms. These are different. Negative 32a squared plus positive 32a squared, that simplifies to 0. So we have 64 a to the 4th minus 16. So these are the special products. The special product is a difference of squares, which means we have a squared expression minus a squared expression, right? N squared, that's our first term, subtract 1 squared, which is 1. The second expression, the first term squared, 8a squared, minus a squared expression, that's 4 squared. So anytime you two binomials that you're multiplying together. They're exactly the same, except, how are these two binomials different? Anson, how are these different? Say it again. Well, none of the binomials are square, but I asked, how is n minus 1 different from n plus 1? Lee? Yeah, one's addition, one's subtraction. Look down here. Everything was exactly the same except one is addition and one is subtraction, right? So that's the deal. In order for us to get this special product, we have to have two binomials. They have to be exact except one has to be an addition and one has to be a subtraction. That's how the middle terms go away. So you can see two identical binomials that we multiply, two identical binomials except one is addition and one is subtraction. It's always going to be this pattern. N squared minus 1 squared. So first term squared minus the second term squared. First term squared, 8a squared, raised to the second power is 64a to the fourth power. Remember, it doesn't mean it has to have an exponent of 2 there. It means you squared that first term. And it's always minus, and it's always the last term in the binomial squared. So that's our shortcut. If the two binomials that we're multiplying are identical except one has addition and one has subtraction, the shortcut is square the first term, and then subtract the square of the second term. It's always a subtract. So we're going to multiply another pair of binomials. They're going to look exactly the same, except one's going to be addition and one's going to have subtraction. What's your favorite number, Naya? 18. So 18n and 18n are going to go there. What's your favorite number, Kayshawn? Oh, Lord, 22. Okay, it's okay. We're going to do big numbers. It's all right. So they're exactly the same, except one's addition and one's subtraction. So the shortcut is square the first term. And I don't know what 18 squared is, but I'm about to find out. Maybe. 324. So 324n squared. Now subtract the square of the second term. So the second term, it does not matter if this is the addition or this is the subtraction binomial. You're just going to square whatever this is. This is 22 squared. And that's 484. Make sense? Okay, so that is our first special product. Learn the shortcut because it's actually unusual, and I talked about this when we first started multiplying binomials. It's unusual for you to get a binomial when you multiply two binomials. Most of the time when we multiply two binomials, we'll get a trinomial, right? Sometimes we could get more terms than that, but for our purposes, normally we would get a trinomial. This one is special though. Multiply two binomials and you get a binomial. That makes that one unique. All right, the second special product, a perfect square trinomial. So we know the answer to n plus 3 squared is going to be a trinomial. We know the answer to 4a plus 7 squared is going to be a trinomial. We are squaring this binomial. we are squaring this binomial, okay? So in order for us to get a perfect square trinomial, we must be squaring a binomial. That's the only way to get this special product. Does that make sense? Now you'll see now, if we square something, the signs are always going to be the same. So let's go ahead and do this the long way, like we did yesterday, the day before. Everybody should be able to multiply this one now. So now n squared plus 3n plus 3n plus 9. So these are like terms. They can be combined. So our final product is going to be our n squared. What's 3n plus 3n? Brooklyn, what's 3n plus 3n? Very good. Plus 6n. And so then plus 9. 4a plus 7 squared. We do it the long way. We're going to go ahead and write it. We're going to expand this and write it as 4a plus 7 times 4a plus 7. When we're using our shortcut, we won't even have to do that. Right, the shortcut, we're going to use, we won't even have to separate them like this. But for now, let's do it the way you learned it yesterday. So, 16a squared plus 28a plus 28a, 16, yeah, plus 49. So that simplifies to 16a squared. Now 28a and 28a are like terms, so we add those, and we're going to get 56a. And we're going to add our constant 49. So if you'll notice, when you square that same binomial, you're going to have duplicate or double middle terms here, right? The middle, we've got two things we're going to add up, and those are the same thing. So we're doubling that. So if we look at what could possibly be the shortcut, well, we'll see that this first term is the square of this first term. Does that make sense, Annabelle? We should see that the last term is the square of the last term, right? So 3 squared is 9. N squared is n squared. Now, how do we get to 6n? Well, if we do it the long way, we can see how we get it. So what could our shortcut be? Well, if we multiply 3 times n, and then double it, 3n times 2, that's how we get our middle term. Does that make sense, Keishan? Does that make sense, Akira? Okay. Same thing here. If we square our first term, 4a, we get our first term squared. Our first term in the trinomial. If we square the second term, we get our last term in the trinomial. Does that make sense to me? And how do we get our middle term? Well, long way, but if we want to use our shortcut, and I want you to try to use the shortcut today, multiply these two and then double it. Remember, doubling means multiplying by 2. The 2 is a magic number on this shortcut. We square the first term and the last term, so we raise it to the second power. And then we multiply them and then multiply by 2. So we're squaring it, raise to the second power, and then multiplying something by 2. So 2 is the number we want to remember. So 7 times 4a is 28a times 2, that is 56a. Does that make sense, Fatima? Make sense, Jeremiah? Okay. So the steps are square the first term, need to be written in standard form, so greatest degree to least degree. So typically our binomials we written in standard form. If they're not, you can rearrange them. The next thing we're going to do is we're going to double the product. Remember, product means multiply, right? So we're going to multiply the two terms and then multiply that by 2. That's what double means. Or multiply them and add it twice, right? Same thing. And last, we square the last term. Both of these are plus, yes, please. When we're through with this example. So these are both pluses, right? They don't have to both have a plus there. It could be a minus. What's your favorite number, Braden? I'm sorry, Brandon? 11. 11. Going to say 11b minus, what's your favorite number, Xavier? 6. Okay. We're going to use our shortcut. It does not matter that this is minus. Now, here's the deal. On the difference of squares, remember, it's always a subtraction. But on the perfect square trinomials, if there's addition here, everything's addition. But if there's subtraction here, you're going to see it's a little bit different. The first thing we're going to do is we're going to square the first term. So 11b squared, 11 squared is 121. B squared is b squared. Now we're going to double the product of the two terms. So the product means we're multiplying these. So it's going to be negative 66b times 2. So that's going to be, we're going to use our calculator for that, but I think it's negative 132b. Someone got a calculator, you can help your math teacher out. 66 times 2. No, it's not 132. What is it? I can't see. Oh, it's 232. 66 times 2 is not 232. What is it? Negative 132. So it's negative 132. Okay. So negative 6 times 11b is negative 66b times 2 is negative 132b. And the last thing we're going to do is square the last term. So the last term is negative 6. Negative 6 times negative 6 is a positive 36. So here's the deal. Perfect square trinomial. The first term always has to be positive. If you square a positive or negative, you get a positive. The last term has to be positive because if you square a positive or negative number, you're going to get positive. But the middle term could be positive or negative. If it's a negative in that binomial, it's going to be a negative middle term. If it's a positive in the binomial we're squaring, it'll be a positive middle term. Does that make sense to everyone? Any questions? Okay. All right, I was going to do, you have 2 word problems, I think, today. Oh, 3 word problems, but actually, one is actually a word problem, but I'm going to do number 14 with you. Yeah, we're going to do this homework problem, but you can do it when you get back. It's 201, honey. All right, so the directions say, find the area of the shaded portion, right? So the shaded is the gray. Everybody understand what they're asking for? So they want to know what is the area of all this gray part. So they don't want the area of this. This is kind of like the problem that we did at the beginning of class that Akira asked about, right? So if we want to find the gray area, that little white area is in the middle of it, right? So we can find the area of that whole big thing, and we can subtract the area of that little square. Does that make sense? Does that make sense, Keisha? You confused? Okay. Let's look at a piece of paper. Let's see if that helps. First one, will you set it for me? Okay. have this sheet of paper here. I want to find the area, Keyshawn, of the white part, right? So really what I want to find the area of I want to find the area of this part. What did I do? Well, I cut it out. Some version of cutting it out, if you're talking math, could be to subtract it, right? So if I only want the white part, I'm going to subtract this part. I'm going to take it away. Okay? So if I find the entire area, the whole thing all together, and then I find the area of the little part, and I subtract it, then I would have the area of just this part. Does that make more sense? Okay. Lost my pen underneath here. Okay. So, the area of a square, well, a square is a rectangle, anything rectangle. The area of a square, you can say the length times width, but a square means that all sides are the same length, right? So, the area of a square is the side squared. So you gotta remember that. That's the formula for the area of a square. So, this square, the whole square, has a side measure of a plus 6. So if we're finding the area of the whole thing, it's going to be x plus 6 squared, right? And the area of the little, the white one here, would be x squared, or x squared. Does that make sense, Jaden? So we can use our shortcut here. We don't really need to use a shortcut here. It's only a monomial times a monomial, so x times x. But this one, we're going to use our shortcut. Make sure you can see your steps from your notes. So our first term is going to be what? What was our first step say we're going to do in our notes, Diane? We're squaring a binomial. We're going to get out, give you a hint, a perfect square trinomial. So what's the first step? Say that again. What are your directions, your steps say in your notes? Square the first term. So the first term is the x, so x squared. What does the second step in your notes say to do, Darian? Look at your perfect square trinomial that you just wrote down, buddy. In the back of your notes. So when you just finished, what step 2 say to do? Very good. Double the product of the terms. So one term and one term. Product means multiply. That's 6x. And multiply that by 2. 12x. Right? Or 6x plus 6x. That's another way to double something, right? Just add it to itself. And then what's the last step say to do, Peyton? Can you know? Square the last term, so we're going to square 6. So that's plus 6 squared or plus 36. So the area of the whole thing is x squared plus 12x plus 36. So they asked for the area of the shaded part. So we're going to cut out the white part. The area of the whole thing, x squared plus 12x plus 36 minus the area of the little one, x squared. Like terms, not like terms, right? So what's x squared minus x squared? 0. So this simplify to 0. They won't always simplify to 0, but in this case they do. So we have 2 terms left, so not like terms, so that is our final answer. 12x plus 36. That is the area of the shaded portion. Make sense, Ulrich? Make sense, Brandon? Brooklyn? Does that make sense? Did you write it all down? You didn't write it down, Brooklyn? Okay, well, I literally did it with you, so you know how to do 16. You gotta stay focused, honey. Any questions for me? Okay. You can go ahead and scan the signature in. Go ahead and get started on your assignment.